Discerning the evolution of Candela's shells through parametric structural analysis. International Conference of Spatial Structures 2020-21. In this research shows the analysis of 3 double curvature shells designed by architect Felix Candela. Los Manantiales Restaurant in Mexico City in 1958, the Maracaibo Country Club Auditorium in Venezuela in 1962, and the Oslo Botanic Garden Shell in Norway in 1965. The results obtained will be compared through a structural analysis using parametric tools in order to observe the evolution of Candela's paraboloid shells, considering their physical characteristics and focusing on their structural behavior. In the Xochimilco restaurant that was created by Candela, is designed intersecting 4 saddles, becoming a shell structure of an octagonal groined poles, composed of 8 segments that Candela had not yet attempted at the time according to Moreira. In the Maracaibo Country Club proposals, it was conceived by Candela in 1962, based on a proposal made by the architect José Hernández Casas in 1959. The project of the Maracaibo Country Club Auditorium in Venezuela was proposed as a multiple-use structure, and although 2 projects were proposed, but it was never built. The first proposed project, developed by José Hernández Casas in 1959, consists of 12 segment structures formed of a translation surface generated by 2 parabolas. In the second proposal by Felix Candela in 1962, show a geometrical evolution in the forming of the shell. It respects the 12 segments of the shell, but the surface generated is with hyperbolic paraboloids. The Oslo Botanic Garden Shell, it was conceived by Candela at the end of the first half of the 1960s and built in the half the Ansbad's Garden of Frognerparken at Oslo, as part of the exhibition Form and Flora. It was demolished on April 1993. In the methodology for the structural analysis of the proposals of the auditorium of the structures built for the exposition Form and Flora and Los Manantiales Restaurant, advanced NURBS modeling techniques will be used with Rhinoceros and complements in Grasshopper. 4 simulations and finite elements analysis will be performed using Karamba 3D, allowing the comparison of the results for the different shells under normal design conditions. In the simulation of the structural behavior of the different 3D models of the concrete shells, the main parameter for its realization is the used geometry, the diameter of the shell, and the number of segments that form the shell that are compared. Other important geometry parameters are taken into account, such as the maximum height of the segments and the distance between the supports. With this geometry analysis, the evolution of their hyperbolic paraboloid shells can be observed, not only of the number of these segments, but also of their design and the structural behavior. In the first stage of the methodology, the assembly model and the analysis components in Karamba 3D are used in order to obtain the weight and the maximum deflection of each of the 3D models of the different shells. Subsequently, buckling load factors are obtained for each of the models using the buckling model component. This component allows to obtain the factors, which are assumed to be non-negative. In a second step of the methodology, using the component shell forces, Principal or local shell's cross-section forces can be retrieved, obtaining the principal shell forces. The order of all results lists corresponds to the order of faces in the mesh used to generate the shell, which is the same order as the principal forces directions on shell's component. In the final stage of the simulations, the maximum displacement of the concrete shells and the buckling deformation that occur on each of the models are obtained. In the results obtained from the 3D models, it's observed that the maximum displacement registered at the are different in each of the models. In the shell for the Oslo exhibition, a maximum displacement of 1.1 millimeter is obtained. In the shell for the Manantiales Restaurant, a maximum displacement of 1.66 millimeters is obtained. Finally, in the proposal for the Maracaibo Country Club, a maximum displacement of 1.11 millimeter is obtained. In the proposal of proposal of Jose Hernandez Casas is obtained of 1 millimeter 0.07 displacement. In this research is concluded that Felix Candela uses geometry and double curvature as a parameter to stabilize a structure, even using structures of complex geometry, developing by hyperbolic paraboloid segments. In the evolution of concrete shells, it is observed that the use of the number of segments will be depend on the scale of the structure in conjunction with the dimension. It can be observed that with an increase of the scale in the concrete shells, the number of hyperbolic paraboloid segments increases to achieve greater stability in the structure. The observed results show that the shells decrease their tensile forces with increasing number of segments and increase their compressive forces, resulting in smaller deformations in proportion to their dimensions. Thank you.